This will be part 3 of our wireless HDMI field monitor project. In the first part, we gathered the components we would need and laid out a plan. In the second part, we made 2 camera mounts for the transmitters, as well as most of the smaller pieces that we would need for the field monitor housings. This time around, we'll finish making all the pieces we need and assemble both of the field monitor units that we set out to build. In order to make that happen, we'll start by cutting out the 4 aluminum plates that make up our 2 housings, as well as 4 more smaller plates that will act as the spacers between the housing and the display. We want there to be about 1/4 of an inch between the display and the housing to leave room for the screw heads, as well as in the future letting us slide a board in there to act as a sunshade. We have a lot of kind of complex cuts to make because, well, I overcomplicated this quite a bit, so I'd better stop talking and get to cutting. Shit. Here we have the 4 pieces of plate aluminum that are going to make up our housings. But as you saw there, things did not go according to plan. So that's a bummer because we can't have the extra features that I wanted, which were mainly tabs on the front pieces of the housing to support the corners and prevent damage to the monitor, and 2 raised tabs for the rear of the multi-receiver setup that would help guide the wires for the batteries and protect them. But that didn't work out, so here we are back to the simplified original plan, having lost quite a bit of time and unfortunately some of that spare material. But live and learn. I kinda thought that might happen. I probably should have tested it before doing all the work filing out the slots for the wires, but it's done, so we'll make do with what we have. Instead of the original plan of having different sizes and shapes of pieces, I think we just want all 4 of these to be uniform. So to make that happen, I think we'll start drilling the holes for the perimeter bolts that will hold the housings together on the final assemblies. Then we can put some bolts through and lock all of these together and sand them all at once so that they're totally uniform. Really, we only need pairs that match, but I figure since they're all going to be the same size now, we might as well just do them all at once. When we drill all these holes, we're only actually going to drill 7 of them because the multi-monitor setup only has 7, as there will be a receiver in the way of one, and I just think it's a better, more uniform look to leave one of them out than have one in a weird location. So we'll clamp these together, drill some holes, bolt them together, sand them, take them apart, drill one more hole in 2 of them, and then I think from there I just want to start assembling things. Once the housing bolt holes are drilled, there are a few more bolts like for the monitor mounts, the battery hold down straps, and the receiver and switch mounts that we'll need too. So let's get back to work. And just like that, our backing plates are basically ready to go. Obviously, they'll need some more holes drilled in them, but that's a bit more application specific, so I think we'll just try to take care of that as we come to it. As mentioned, for the single receiver unit, we have 8 holes around the perimeter, and for the multiple receiver unit, it only has 7. As far as getting the material for this, I think in the end it kinda did work out. Because if this material was any thinner than what it is, it might have been a lot harder to work with. It probably still would have been okay once it was all bolted together, but it would have been a lot harder to get it to this point. There's one last thing we need to do, and we can start trying to assemble one of these. The housings won't be mounted flush against the back of the monitors. They need some spacers so that the bolt heads have room. For that, we'll cut up this 1 inch wide, 1/4 inch thick strap aluminum. We'll be making 4 of these spacers in total, each with 2 bolt holes for the VESA mount. Let's get those taken care of. Here we have our 4 spacers that will mount between the monitor and the housing to make sure there's enough room for everything. While we were marking these out and getting ready to drill them, we were using this as a template. This kit is pretty nifty. This is a quick detach adapter for mounting a TV or monitor with VESA standard bolt patterns. This stamped steel plate mounts to the back of the screen, and when it is slid down into place on the adapter, clicks into place. It's not exactly a tight fit, but it's mostly relying on gravity, so it's probably fine in most applications. It uses this little latch to hold this mount in place, and once you depress that, it can slide right off. This is way faster and more convenient than unscrewing the monitor from its mount every single time. And it seemed perfect for this project since the field monitor can go from being handheld to clicked into a stand pretty much instantly. We'll be mounting this plate to the back of each of our monitor housings. We'll also be able to use it as a template to drill the holes through the plate aluminum that we're mounting directly to the monitor. This side is going to need a stand. I don't have anything sitting around, and I didn't see any cheap monitor stands on the market that were really what I was looking for. So instead of just going and getting a monitor mount, I have a few ideas for something we can make that would work perfectly with this monitor. Which is why we've bought several of these kits so that we can have different mounting options. For example, I'd like to put one of these right here behind the workbench so that I can have the field monitor showing me what the camera is seeing so I can actually tell. It would make tabletop videos like this one much easier. But we'll get more into that stuff later. For now, we have to actually assemble one of these things and make sure the concept works. And the assembly, along with drilling some more holes and routing a whole bunch of wires, is pretty much all that's left. We'll start with the single receiver version since it's a much more simple system and it'll tell us if this is going to work at all. I'm really excited that we're almost ready to have one of these things on the table in front of us, so let's get to work. Finally, after all that talking and all that work, we have something to show for it. This was the first assembly of our single receiver monitor system, and we've had a lot of setbacks along the way, but in the end it all came together. This is by no means a final design, and I already have some ideas for things I want to tweak and change. This port we cut in the back gives us access to the battery level indicator and the USB ports where we can plug in the receiver and screen. This needed to be accessible so that the battery could be relatively easily removed, and because right now there's no other way to power these devices on and off. I have a plan for setting up a little toggle switch panel, but that won't happen in this video. The handle is nice and sturdy, which is something I had originally worried about, and while nothing on this is perfectly square since, well, I made it, it does sit pretty flat on the table and is actually quite stable. Right now, the handle is mounted against the front plate, which means it is quite centered as far as weight and center of gravity goes. But I also wanted to use this thing handheld in an over-the-arm way, and it's a little bit, maybe even just like half an inch or a quarter inch too far forward for that to be super comfortable. Though the other thing about holding it this way is that it's a little bit heavier than I expected it to be, so it's not the most comfortable thing. This slot we cut on the side is the pass-through for the HDMI and power cables for the monitor. The only reason it has to be so long is to fit this relatively large 90-degree HDMI cable through it. But I think it looks tidy enough, and I'm pretty happy with how this slot and the access port on the back panel came out. Both of these wires are below flush with the edge of the housing, although I wish there was a little bit more protection if it got hit on the corner or something right here where that cable is. The original plan for these plates was to leave tabs on the corners with about an inch of material all the way around so we could fold them up, and that would offer a little bit of protection for the monitor in the corners, the plug, and then we could lay it flat without the weight resting on the screen. But since we didn't have any luck when we tried to bend this aluminum plate, I made the decision to just scrap all of that and go back to the original simple design that I had envisioned. I ended up deciding kind of at the last minute to mount the receiver up top for theoretically better reception, and as far as heat dissipation and signal goes, it probably is better for this to be mounted right up top. I don't remember if we actually talked about this at all, but this is a micro USB extension for the battery so that we can leave the battery installed and still charge it. Otherwise, the charging port is all the way back here, and it would not be the easiest thing in the world to plug a power cord into it. The mounting for that was just 2 drilled holes and a zip tie holding it down. I think it would be better and it would make the port a little bit more stationary if we came back and made a tiny little plate to clamp it down with. The monitor is also pretty flexible, so I think it would be good to space out these bolts. We can get away with at least one washer on each of them so that the bolts themselves can prevent the monitor from flexing too much. If you look down at the base of the monitor, you can see that the bezel is no longer sitting flush with the display. I'm pretty sure this has something to do with those VESA mount threads, but it doesn't seem to be hurting anything, and I'm not really sure what we would do about it anyway, so I guess we're just going to ignore that. The last thing we're going to do with this monitor right now is drill the mounting holes for and attach our quick detach VESA plate. It should be positioned right about there in the center of the whole housing. The top priority is just finishing both of these units, so the actual mounts that this attached to are going to have to wait, but it would be good to get this set up right now. We'll go ahead and mark the holes we need to drill, remove the back plate to drill them, screw down the plate, and then reassemble the monitor. we were able to bolt this VESA quick detach plate right to the back of our housing. Now, whenever we do get around to making mounts for this, the monitor can just click into place on them, and the latch prevents it from lifting up. Once that's been depressed, the monitor comes right off of the mounting plate. We still have to build the mounts for this going forward, but at least for now, this part is solidly in place. I also relocated the little micro USB extension for charging the battery. Now these two bolts are holding it in place very solidly. It's probably a bit of overkill, but at least it doesn't move around now when you try to plug a wire in. And through the indicators visible through the back of the housing, we can see that the battery is charging. These batteries are able to charge and output power at the same time, and it's probably not the best for the cells, but if we're doing it for shorter periods of time, I doubt it would hurt anything too badly. Of course, that one little micro USB power port won't be able to provide as much power as it can output, but having it plugged in could prolong the life of the battery a fair amount. We also took some 3M double-sided tape and attached this. This is the infrared sensor that plugs into the receiver, so you can use this little included remote to access a few functions. Mainly, going through this menu is the easiest and quickest way to change the channel that the receiver is tuned to. The range of this remote is pretty limited, so it pretty much has to be right on top of the sensor to work, but we can see it allows us to scroll through and choose exactly the channel we want from a list, which is better than scrolling through one at a time by pressing the button on the receiver. I considered just mounting one of these remotes to the front here or something like that and just having the infrared emitter right in front of it so that it couldn't miss, but I don't think we'll be changing the channels all that often, and that seems like a little bit of overkill here. So we'll just keep at least one of these remotes handy in case we need to change these channels. While this was apart, I did a test where I moved the handle to the back side of these spacers, which meant it was mounted flush against the back plate instead of the front one. I thought it might make this holding position a little bit easier, but it actually ended up being less comfortable for me. In this position, the handle is more centrally located as far as center of gravity goes, and it's a bit more comfortable, so it's definitely where we want it to be. And with all that, well, I think we're about done. At least for now. This probably will see some changes in the future, and I already have some ideas, such as wiring in some small toggle switches to each one of the power lines so that we can turn on and off items without just disconnecting the USB cables. For now, pulling power by just unplugging those cables is fine, but if I have some time in the future, I would like to make it a little bit more legit. For right now, though, there is another pretty significant part of this project that we're going to tackle, and that is this second field monitor unit. This one will be built very much like the first, and we'll use some of the lessons we learned building that along the way, but obviously it'll be a little bit more complex. I also decided that we're actually going to mount these batteries inside of the case of the unit instead of on the back. All we'll do is make the space between the plates and the housing a little bit wider. There will be a bit of open air there, and it might look a little bit funny, but that air is good for cooling, and we'll at least be able to fit everything inside of that plate housing. I already went ahead and measured everything, and we're going to need at least 2¼ inches of space inside of that housing. Which is actually a bit of a stroke of luck and is pretty handy since that first housing was 1 3/8 inches, and these 2-inch bolts were a perfect fit for the housing, so a 3-inch bolt should be a perfect fit for our bigger housing since we need it to be approximately 1 inch wider. This does mean that we made some of these spacers for nothing, because obviously these are going to be too short. So in addition to fitting all of the parts in the housing together and adding some slots here and there, we'll also use more of that 1/2-inch solid aluminum dowel to make longer spacers. We'll need those before we can get the rest of it together, so let's get to work making them. Well, it took a lot longer than expected, as these things often seem to, but we have finally finished our multi-receiver field monitor. As you saw, assembling all the components inside of this was a challenge, and the wires, while they're as organized as I could make them, and there are a lot of zip ties holding things together in there, they're still kind of a mess. But we were able to get everything to fit inside of the housing and didn't have to make any significant modifications to the design. Even though it's not showing anything interesting at the moment, we can see that it is powered on and working because we have a split screen of those 4 receivers. I'm really glad that in the end I decided to have the batteries on the sides and leave the center open, because we actually needed almost all of that space to fit the wires. With a fair amount of work, we could shorten some of these wires to reduce the mass and weight of the unit just a little bit, but I just don't feel like the effort to benefit ratio is in our favor there. I don't feel like the bundle of wire is going to cause problems, so we'll just leave it in there for now. Just like the smaller unit, we power everything on and off just by plugging in or unplugging the USB cables. They're very easy to get to through the top panel, so it's not a problem to turn on or off, and we can choose exactly which receivers we're using if we don't want to power on all of them. At the moment, I have it set up so that the monitor, the switch, and the first receiver are plugged into one battery bank. The other battery is powering the other 3 receivers. This way, if we want to just use this as a single viewing monitor, we just plug in the one battery. Thinking about it, it probably would make more sense to split those up between the 2 batteries. That way, the power draw would be more divided, and we would get more battery life by using both batteries, even if we only have one receiver in use. But that's just moving 3 or 4 zip ties around, so if I decide I'd rather have it that way in the future, we can make that change. Up top here, we also have the 2 charge port extensions for our batteries. Since the housing is so tall, even if a wire is plugged into the back here, it does not interfere with the handle. Also, just like the other unit, we have an infrared receiver up here in the right-hand corner. This is only hooked into the first receiver, and we would use that if we wanted both of these field monitors to display the same image from one transmitter. We probably won't be changing channels on the other receivers, and it would just be confusing if we had more than one of these units. So, at least for now, the remote control will only work with the main receiver. We used a hole saw to cut this hole in the backing plate so that we can reach the power button on this battery bank. The button for this side is accessible simply around the edge of the housing. This port makes it much easier to press the power button if we want to check the level or manually power on the battery. These ports are to read the battery level indicators, although unfortunately I didn't get them centered in the most aesthetically pleasing way. I also ran out of the little metric M7 washers I had been using for all of the housing hardware, so we're just using these regular 1/4 inch grade 8 washers. Really, entirely for the aesthetic, I will get more of those M7 washers and come back and switch these out. Just like the other monitor, a big part of the design was simple disassembly. In order to remove this back cover, all we have to do is remove the 7 housing nuts, unplug the USB cables from the batteries as we would when just turning everything off, and the back plate with the batteries still attached to it will totally separate from the rest of the unit. If for whatever reason we need to get access to the components or wires in here, it is easy to do. And of course, the switch is mounted at the side so that we have easy access to the controls for the monitor, as well as the indicators and control buttons for the HDMI switch. I don't think I can really overstate how much time and energy I spent researching, finding parts, planning for, and actually building these systems. It has been a relatively spontaneous and incredible project that I've been able to work on. At the end of this video, to the best of my ability, I'm going to try to list all of the parts we used in these units with model numbers and prices for everything. But other than the wires and some of the building materials, not a single one of these components was something we paid retail price for. As mentioned before, the monitors and receivers came off of eBay, the monitors were sold by a reseller as open box items, and the wireless HDMI receivers, I believe the person I bought them from got them from a business liquidation. So unfortunately, these particular models are not going to be easy to find, and even though I bought as many as I could from the seller, I only have one set that's a spare. So if pieces go missing or I have a hardware problem down the line, it might not be an easy thing to find. The battery packs were bought off of Amazon as renewed items at a very discounted price. And the HDMI switch was an Amazon warehouse item, missing the remote and AC adapter, priced at half off. I did make some wires for this project, but only one of them, the one for that HDMI switch, actually ended up in the final units. The rest were purchased from a variety of sellers on Amazon since I was trying to get everything in a hurry. Even most of the quick detach VESA adapters were Amazon warehouse items at a discounted price. I'll do my best to come up with a total cost for this project, although some parts like the aluminum plate I already had sitting around. I haven't actually done the math yet, and I'm a little bit afraid to because I think it might be a bigger number than it is in my head right now. But for what we managed to accomplish here, I think we got a pretty good deal. There's still a lot of work I would like to do, and perhaps the main thing is making some mounts for these. So in the near future, we'll have at least one more video for this project where we'll cover that and probably put these systems through their paces. Because while I think they're incredibly cool, it kinda remains to be seen how actually useful they are. But after all this work piecing everything together, I can't wait to find out.